The production of this show is made possible by the support of viewers like you. Please visit conversationsthatmatter.tv and become a subscriber. So, welcome to Conversations That Matter. Each week our objective is to address an issue that we believe is shaping the future of British Columbia. I invited you to come and talk to me about pipelines and the movement of oil across the province of British Columbia and even out onto the coast. Before we get started, maybe you could tell me a little bit about yourself. How did you get into this business? What's your experience?
Well, that's kind of you, Stu. Thank you for having me on the show, and I'm looking forward to having the conversation with you. I do often ask myself, how did I get this job? Get to do a lot of interesting things these days, and there's certainly a lot of interest in pipelines, a lot more than there has been over my career. I grew up in the Lower Mainland. I was born in Victoria. I grew up in Coquitlam. Went to UBC. Got a mechanical engineering degree from UBC and a business degree from SFU. And the first part of my career was on the gas side of pipelines. I worked for predecessor companies at Kinder Morgan. And in 2005, they asked me to move to Calgary to work on an earlier version of this expansion project.
And Trans Mountain transports what kinds of products?
Well, it's an petroleum pipeline. So we move oil-derived products. So we move everything from highly refined products for blending in gasoline, diesel, and then crude oil for feedstock for refineries and for export. Yeah, so the pipe was originally built in 1953. It was built out of Cold War concerns for Cold War energy supply on the West Coast. It's the only pipeline that serves the West Coast of North America. So it's the only
pipeline that serves the West Coast?
It's the only oil pipeline that connects to the West Coast of North America, yeah. So
there aren't even any in the United States?
Interesting fact, yeah. So there's pipelines, and there's natural gas pipelines, and there's pipelines that move product, around refined product for delivery. But on the West Coast, today we move 300,000 barrels a day, again, of a mixed range of petroleum. We have a branch that goes off and feeds the 4 large refineries in Washington State. We load tankers at Westridge, at our Westridge terminal. And to the Lower Mainland, we deliver the gas, and the gas that's in your car today came through our pipeline, either as gasoline or would have been refined at the Chevron refinery here locally. But on the West Coast of North America, the other big market is California. So Canada produces about 3 million barrels a day of oil. About 1 million of that we use internally inside Canada's own economy, and the remainder is exported. And the only trading partner that we have today is the U.S. So the 2 million barrels a day roughly of oil is exported. It goes to the continental U.S., which is where all the pipelines go. They sort of go south and east from Alberta.
So when you load oil onto a tanker in Burnaby,
yes,
where's it going to?
About 80% of what we load at Westridge goes to California. So our pipeline provides access to the Pacific Rim. So there's a lot of talk about Asia. There's obviously a big growth story in Asia, and that's an important growing market. But today, most of the oil that we're loading by tanker is going to California. In the future, with our expansion, we expect that to continue. So we expect California to continue to be an important market. It's one of the few markets in the U.S. that doesn't have a lot of supply from Canada.
You're looking at expanding capacity coming into Burnaby. To what? Like what's the expansion going to take us to on a per day basis?
Sure. So today we have a pipeline that moves 300,000 barrels a day. The objective of the project is to twin that existing pipeline. So that means building a second pipeline. It'll essentially be in the same right-of-way. So we have a dedicated 18-meter strip of land that the existing pipeline's buried in. They had the forethought in the 50s when they built this to build that pipe off to one side within the right-of-way. So there's space within that existing strip of land to build a second pipe.
So that original pipe has been in the ground for more than 60 years. It's a long time.
Yeah, a little over 60 years, yeah.
Do pipelines wear out?
Well, that's a good question. We get asked that all the time. An analogy I often use is it's a bit like a car. If you don't maintain your car, it will eventually stop working and wear out. But if you continue to replace parts and you do whatever is required to keep it in top condition, you can continue to run that car for an indefinite amount of time. So what we, sorry,
Yeah, well, a car's above ground, a pipe is under the ground. How do you monitor and maintain that, especially if you're looking back at pipe that is 60 years or older?
That's a good question. So the pipe, first of all, we had very good pipe. You know, back in the 50s, it was sort of post-war, and there was one of the big challenges back in at that period was actually getting an allotment of steel to build the pipeline. It was post-war, and the economies were still recovering, and we were very lucky in that we got steel from some very good mills, and so the quality of the steel is very good. The pipe has a coating on the outside that's tar wrap coating. And it also has a cathodic system, so it has an electrical current that's impressed on the pipe to protect it from corrosion from the soil around it. So it's got all of those things. In terms of monitoring the pipe, we have tools that are run through the pipeline, and this is something over the last 20 years or so has become more and more sophisticated.
Is that what they call a pig?
Yeah, so it's not a real pig.
No.
It's an acronym for Pipeline Inspection Gauge.
Yeah.
And so these are tools that can be inserted into the flow of the oil in the pipeline. And they run through sections, maybe 50 to 100 kilometer sections of pipe at a time. They use technology that's similar to what's used in medical science. So either magnetic resonance imaging, kind of a magnetic flux technology, or ultrasound. And so there'll be sensors on the front. So the magnetic ones, for example, there'll be a whole suite of magnets on the front of the tool. As it runs through the pipeline, those magnets create eddy currents in the steel in the pipeline. And then there's sensors on the back of the tool that can pick up those currents that have been created by the flux of the magnets going by. And also on board is a hard drive that records the signals that are received on those sensors. And then it also has it'll have a very sensitive gyroscope. And so it knows exactly where it was when it started its run, and it will keep track of where it has gone through the pipeline. And so what comes out at the end is you have this hard drive that goes away, and there's people who will analyze the sensor readings on there, and they can detect features in the pipeline before they're injurious or they're a risk to the pipeline. So we will monitor those.
They can sense if there's deterioration.
Yeah, they can identify whether there's a pit or a crack or a dent or things like that. Those are identified, they're cataloged, and then between subsequent tool runs we can monitor whether any of those features are changing. And with every tool run we have, and as part of an ongoing program in the pipeline, every year we have a dig program. So where we're going and digging to either repair, so you can weld a sleeve around the outside of the pipe if there's a feature in there that needs to be addressed, or you can actually just go in and cut a section of pipe out and replace it.
Are there special components around the steel itself?
Well, I think the biggest changes in metallurgy, the big leap forward was World War II in terms of welding, modern welding techniques and better understanding of metallurgy and composition. So the pipe that we have today is built post-war, and it's done with that post-war knowledge of welding. Looking forward with the new system, just along with technology, they're able to better measure and manage the content in the steel in terms of its core metallurgy. The manufacturing process for making the pipe hasn't changed that much. I mean, it's still many of the same techniques that are used to build it, but there's better knowledge, better control of the content of the steel. And then in the field today, pipelines like the one we're building would be use automated welding. So there's often it's almost like a robot that will do the welding for the pipeline
inside
system.
of the pipe?
Well, it's welded on the outside of the pipe.
Okay.
And then the other thing is the coating technology. So while we have really good coating on the original pipeline, this sort of tar wrap process, it was pretty horrible to apply back in the day, and there's been continued sort of advancement in that space as well too. And so now what's used tends to be kind of an epoxy type coating that's quite robust and is proven to be quite reliable.
So I had a conversation with Owen Madden from the Wilderness Committee, who's vehemently opposed to anything to do with pipelines, and he told me, he said, because I wanted them to say, well, what is it exactly about a pipeline that makes you go no to pipelines? And he was quite open about it. He says, pipelines are just an excuse for me to be able to talk about climate change. And throughout our conversation, he finally reaches a point where he says, well, a pipeline is just a piece of metal in the ground. But he can't help himself. He throws in, but inevitably they're going to leak. Just take a look at Kinder Morgan. And I think, what's the safety record of pipelines?
Sure. Well, I think if you look at the range of options for transporting the petroleum that our whole modern society works on, pipelines are at the top of the list in terms of the safest means to move large quantities over a long period of time. Our pipeline, we've had an exemplary safety record on the Trans Mountain system back from when it was built. We've put a list of all the spills that we've had. It's up on our project website. It's there for people to see, and it's part of the discussion that we're having with the expansion. You can never say that there won't be a spill from a pipeline. We've never said that. We never will. We have the people that work in our company are very much focused on preventing that from happening.
What do you say to somebody who says, yeah, I know that you talk about safety, but is it really important to you? How do you get that message across that it is? Because also, I can't help but wonder, what are the consequences of safety not being a number one priority?
Well, it's interesting you raise it that way, because at times I do find it hard to articulate because it's just so core. I mean, we have probably about 400 employees at Kinder Morgan Canada. And that's the primary focus for what we do is making sure that the petroleum, the products that we move are moved safely. We're not in the business of moving petroleum. We're in the business of safe petroleum transportation. And there's all sorts of ramifications, if it wasn't done that way. And frankly, these days, besides all the obvious things about public safety and environmental concerns, you also wouldn't stay in business very long if you weren't doing a good job of this. And it's a very highly regulated business, so it's not just us. So we have people who spend their whole career worrying about how to do this safely, and that's what they come to work every day doing. And then there's also regulatory agencies where there's people that are doing the same thing, making sure that there's oversight and checking up on companies like ours to make sure that they're doing the right thing.
Could we function without your pipeline into the Lower Mainland? Like, what would happen in British Columbia if you weren't doing what you're doing?
Well, it's a pretty fundamental piece of infrastructure. And if we look around here today, or people who are watching this in their homes, if you look around in a modern environment, there's very few things that you will see, certainly indoors, that weren't made possible by energy, certainly petroleum. So it's the obvious things like getting to work every day, by car or by bus. And the less obvious things are, the fact how our food gets delivered to grocery stores. Where does our food come from? How does it get grown? How does it get delivered through the supply chain to local supermarkets and things like that?
So your desire to increase the capacity that can bring oil to the coast is to do what? Like, is it to continue to fill an expanding need, or is it to be able to sell it to other markets as well?
Well, today there's not enough capacity in the existing system to do all the things that are asked for us. So the pipeline is chronically oversubscribed. So every month we have requests for more space than the pipeline has to offer. So to be clear, our business, we don't produce the oil and we don't refine and make gasoline. We're the analogy I use is we don't grow the wheat and we don't bake the bread. We move things in between for people. So the producers or refiners that want oil, Canadian oil, every month they're asking for space on the pipeline, and we don't have enough capacity to satisfy all the needs. The big area of growth is increased supply to California and increased supply to Asia. There's a lot of demand there. So what the producers and refiners have asked for is they've asked for more capacity. And what the project is really about is about providing access to Canadian oil to other markets. So today, as I said, we said at the beginning, is that the way the pipe network in North America works is all the plumbing really goes south and east into the States. all the way down, essentially down into Texas now. So that market is very well served by Canadian oil. But what's happened over the last few years is that the price of oil in the U.S. is relatively less than what it is offshore, what the rest of the world is paying. And that's because of a slowed economy in the U.S., some demand destruction there when we had the big financial meltdown in 2009. There's some uses of oil that just went away. But it's also because because of new drilling technology, there's a growing source of supply within the U.S. And as that supply comes on, it's reducing the U.S.'s need for Canadian oil. And so Canadian producers have essentially a shrinking market. And they don't have any ability to access any other market. So our project is about trying to provide access to an alternative market to the U.S. Today, the price of oil in the U.S. is quite a bit lower than it is offshore. So in California, they're bringing their oil in by tanker, and so they're paying kind of a world price. Once it's on a tanker, you can take it anywhere, and so the prices are similar around the rest of the world. And Asia is importing oil from other countries as well too. And so there's quite a price differential between the two of them. Now those price differentials won't always be there, but this is the key to our project, is that when they exist, as they have done now for several years, Canada isn't in a position to take advantage of them. So Canadian producers, although there's this attractive price elsewhere in the world, they can't get their oil there because there's no pipeline access. So that's really fundamentally what's driving our project.
One of the issues, increased tanker traffic in the port of Vancouver, is going to skyrocket as a result of this project.
Well, it's certainly, the project would result in more tankers than we have today. There's no question about that. And in terms of our terminal and the traffic in the eastern part of the harbor, it's a material change. I mean, today we load about 5 tankers a month. If the project was approved, we would see that increasing. And if it's approved and the pipeline's running full, what it's designed for is it's designed to serve up to 34 tankers a month. But if you think about that in terms of perspective for the overall shipping that's coming and going, I mean, the Port of Vancouver is Canada's largest port. Today, tanker traffic represents only about 2% of the total ships that call, the total traffic in the port. If the project's approved, it would go to, our part of the traffic would account for about 7%.
Now, we're not talking VLCCs here.
No. Just as much because of the geography of the port, there are restrictions at second narrows that limit the size of vessels that can transit through that area. And without getting into too much technical jargon, it's an Aframax-sized ship. And so if you look at the fleet of tankers, the smaller end is the Panamax size. So this is a vessel that's designed to be able to transit the Panama Canal. The next size up from that is an Aframax, would be about 265 meters long and 44 meters wide. And those are the largest ships that call at our terminal today that exist now.
Are those tankers currently tethered? Are they using that tethered tug protocol?
They do. Today, there's rules that are set by Port Metro Vancouver and by the Pacific Pilotage Authority that lay out where tug escorts are required. And so through Vancouver Harbor, the ships have 2 large tugs that are tethered to the stern, and usually 1 or 2 on the bow as well. And those tugs stay with the vessel through second narrows. The 2 tugs on the stern stay all the way through to English Bay. And then through Boundary Pass and Harrow Strait, so essentially through the Gulf Islands, from Saturna Island to Victoria, there's a single tug that's tethered to the stern. The reason there's only 1 in that portion is because the channel's much wider, and so there's more room in order to deal with maneuvers. Whereas in the port where it's more restricted, there's more tug horsepower attached to the vessel to be able to keep it on a narrower path. And both the tug masters and the pilots have practiced both in simulators and in real time maneuvers where if there was a failure of the ship's system, so for example if the rudder went hard over just as it was coming towards the bridge or some other key intersection, the tugs are able to maintain the tanker on its path and stop it if necessary, take it to a safe anchorage.
No doubt in people's mind will be the Russian container ship that was up off of Haida Gwaii. And people will be saying, but what happens if it loses power?
Sure.
When we're in coastal waters, is there room for concern there?
Well, and that's largely what these tug escorts are there for, and it's what sets tankers apart from other types of vessels, like the Russian freighter that was in the news recently. the tugs are actually attached to the vessel. And they're there for exactly that. If there's a failure of the ship systems, if the engine stalls, or if the rudder doesn't respond. With our project, as part of the work that we've done around our risk assessment for the project, and it's part of what will be reviewed by the National Energy Board, we have proposed that the additional sections of the transit between Westridge and the mouth of Juan de Fuca would have a tug. A tug would be available to escort the vessel as well too. So there's already today, under current regulation, there's a requirement for tugs through the harbor and through the Gulf Islands. And what we propose is that a tug would stay with the vessel between English Bay and Saturna Island, and then from Victoria out to the mouth of Juan de Fuca. And that tug would be there for exactly what you were just asking about, which is if there was some, the unlikely event that there was some failure of the ship systems and it needed an assist, instead of having to rely on a tug to be dispatched from somewhere, the tug would be right there with the ship and would be able to intervene.
What's the safety record so far on movement of those tankers?
Yeah, well, there's never been a spill from vessels calling at tankers calling at Westridge, and I'm not aware of any tanker-based spills out of Vancouver Harbor for as long as records have been kept.
I know you can't give absolute guarantees, but people who are opponents will always say, well, ultimately it's going to happen. Like the odds are just that it's going to happen. When somebody brings that up, they go, but come on, Mike.
Yeah, I've heard that. I've heard that a lot of times. I've heard people say, it's not a matter of if, it's just a matter of when. And I think one has to look at all the safety management systems that are in place. We've looked at what the chance of a large spill is today based on the existing traffic from our terminal, and it's something that has a return period of about once in just over 3,000 years. Now you have to look at that in terms of the time scale of the project as well too. The project,
right.
The pipeline today we've had has only been in place for 60 years, and if we make progress on fossil fuel, alternatives to fossil fuels and other things, I mean, the economic lifespan, or the commercial, let me put it this way, the commercial underpinning for the project is probably about a 30-year basis.
Thank you very much.
Yeah.
I really
Thank you, Stuart. I appreciate the
coming and doing
opportunity.
this. Yeah.
Thanks for having me.
Thanks a lot.
Thank you.
Yeah.